Hi, class. This is Dr. Nerz. I'm in the lab, and this is like one of our last techniques, which is to learn how to do column chromatography. Okay, column chromatography is like a large-scale version of thin layer chromatography, which we've been practicing for weeks now. Okay, thin layer chromatography, what it entails, right, is there's a solid support like plastic or aluminum, and on front of it there's some silica gel and a binder. And remember, silica gel is really polar. Silica gel is very hygroscopic, so if it sits out, it picks up water, and that changes its properties. Remember, that's the little packets they put in your shoes to keep your shoes dry. Okay, so there's a thin coating of silica gel on here, and what you did right last week was you took a little bit of flutamide that you made and you spotted it on the plate. You spotted it versus some of your starting material, and then you ran it up in dichloromethane to see if you had made any product and to see how much starting material you had left. And remember, the basic concept of chromatography is that of all chromatography, you have a mobile phase, you have a stationary phase. The stationary phase in this phase is the very dry silica gel. If these sit out, they're no good. Very dry silica gel, which is polar, it's silicon oxide, and then the mobile phase is the dichloromethane or whatever solvent system you choose to use that moves up that plate. And what you do is you apply the sample to the plate, it sticks to the silica gel. When the solvent starts moving by, you create an equilibrium between the very polar silica gel and the solvent. Okay? If the compound is more polar, it'll spend more time on the silica gel and it'll move less up the plate, right? And if it's less polar, it spends more time in the dichloromethane and it moves higher in the plate. And then you visualize it somehow, such as using UV light or the para-anisaldehyd stain that we've been using. Realize this is going to be an integral part of column chromatography. So, if you have a good separation on a plate, that means in principle, on large scale, you can get a good separation on a column. Okay, so we're going to use the exact same material but in loose form, absorb the compound onto this material on a column, and then elute it off with the same solvent, because what we did on the plate was a good model. Okay, so if you saw some separation last week, you're going to see some separation here as well. Realize the way we monitor what's coming off the column is with TLC plates, so that's an integral part of it. All right, some of the columns look like this, and they actually have a stopcock on the bottom. I am slowly acquiring these stopcocks. These may or may not work well, I'm not sure. This is my crude way of doing it. My crude way of doing it, these have luer lock bottoms. I just put a needle in the bottom. This was one thing I just did on a Sunday afternoon when I had no way to stop the flow of that liquid, okay? Now, the column, again, is going to be just like the TLC plate. All right, so how do you do this? One thing you have to do, you'll notice with these columns, is these columns have what's called a frit in them, which is like a little piece of glass. It's kind of like the sintered glass funnel you used a couple weeks ago. I'm going to fill this up, okay, with some dichloromethane. Now you'll notice everybody's got their own way of doing this. Graduate students do it every single day. This is how organic chemists in a academic lab typically separate things. You have to put a little sand in there, and you just put the sand to kind of create a little barrier between the bottom and the needle. Now I'm putting the sand in late. Some people have criticized me for this, and notice I'm not even using a spatula. I'm going to use a spatula. All right, I'm just going to put a little scoop of sand in here. The sand just it makes this nice flat barrier at the bottom. Now this is the messy way to do it. The neat way would have been to put it in before I put the solvent in, okay? But it doesn't matter because I'm going to fill this thing up with solvent, okay? And when I fill it up with the solvent, it'll clear off the walls and all that sand will fall to the bottom. It's very dense, so it's falling to the bottom. I'm filling this up, okay? But this is not the column. This is just the solvent. This is like the solvent being in the bottom of your TLC chamber waiting for the plate, okay? Now, anytime you want to get this thing flowing, what you do is you just pull that off, or if you have a stopcock, just open the stopcock. Okay, but you got to get the hang of the stopcock. All right, now, slurry packing, okay? Inside this container, I have 7 grams of silica gel. There's a particular ratio that's used for separation. I think if you have about a gram of compound, use about 50 grams of silica gel, and you need kind of a big column. We're working in the land of micro scale. Really, 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 really small scale. And a lot of you guys aren't there yet. Everything you should be using should be the tiniest thing you have. I don't want to see any more gigantic. I saw them last like Wednesday or Thursday. Gigantic vacuum filtration apparatus. Last week you were working on a 0.1 gram scale. That is sub-micro scale. You should not be using a container that is meant for like 10 grams of material when you're working with 0.1 gram. I hope that's starting to make sense, because that's not what you do in your kitchen, right? You wouldn't use a gigantic pot if you're making a tiny bit of something. I hope you wouldn't anyway. But in here, this is like the amount of silica gel you would need for a micro separation, for about like 200 milligrams to 300 milligrams of material. It's probably a little on the generous side. Now what I'm going to show you is slurry packing. And when you slurry pack, what you do is you take your eluting solvent. Now why am I using dichloromethane? I'm using dichloromethane because that worked well on the silica gel plate. And again, the plate is a model for the actual column. Now you'll notice when you add this, you don't have to use a squeeze bottle, by the way. We have this out in all different forms. I'm just using it because it's easier. But we have all kinds of DCM out in the lab. And we have it on a pump. We have it. You could just get a container of it. Okay? So I'm putting this in. All right, now you'll notice what happened. It went from looking like a white solid to looking like kind of like a slurry, and it has this sort of like glassine or sort of opaque look to it. If it's opaque like that, you put enough in. I'm going to put a little extra in just to be on the safe side. Again, this is what we would call a pretty small column, not a huge, tiny column, but pretty small. So this is what you do. You open it up and get it running, and these are going to run fast. Okay, so it starts running fast. It'll run slower once I get some silica gel in. Now I'm going to start pouring the silica gel in. Now what you will notice as I add the silica gel is the silica gel kind of starts tumbling down. And you see on the top? You see what's happening there? So I'm going to keep adding it. So it kind of coalesces. I'm going to keep adding it because I have a lot more to add. It kind of coalesces. So on the bottom, it'll look the densest, and on the top, it'll look the least dense. And when it gets to the right density, which is the density down here, it's packed. So I don't know if you can see that on the camera, but it's denser down at the bottom than it is at the top. And this is like percolating down as the solvent is running by, and it's creating the actual column right here. And this is the column of silica gel. It is not finished when it looks like this. If you see a low density area and a high density area, it's not finished. Now I haven't put it all in, so I'm going to put more in. Notice as it gets silica gel in there, it starts slowing down a little bit, which is good, because if it kept running at that rate, you'd go a little bit nuts. The column can never run dry, ever. Do not ever let it run dry. If you let the column run dry, you're going to have air pockets in it, and if you get air pockets in it, it's going to be really nasty. Okay, so we're getting there. I hope we can make it through. Okay, I've been having trouble with the cameras today, so let's hope we make it. All right, so we've got it loaded. Now it's running. Wait. When you get to this point, wait. Now I've got it all in. I'm waiting. All I'm waiting is for that to settle. It should take a couple minutes. Now, in the meantime, what should I do? I'm going to put a very beautifully colored sample up on this. This is actually warfarin, which is the kind of faint reaction you're going to do. This is a warfarin sample I made up about 3 years ago, and it's still good. I use it all the time. I call this my emergency warfarin sample. When you're going to load something on the column, I'm doing this in a very crude way. Okay, you're going to actually measure something out and you'll weigh it and everything. But when it's loaded, it should be loaded in the same solvent that you're running in. Otherwise, you're going to create like a crazy polarity shift in the column. So what I'm going to do is I'm going to load this material on the column. So I'm going to also show you how to load. That's like the last thing I have to show you. All right, so this is coming along. What I see now is low density, high density, bam. We just got the column. This is the column right here. And you'll notice the flow rate has slowed down a little bit. Now I've got to run that down, so I'm going to run it. Now, beginners, it's good to put sand on top of the column. I hate putting sand on the column because it just gets in the way of my work, but I'm going to put sand on it, okay? So I'm going back to my sand jar. This is just like very clean sea sand, okay? The reason you guys need sand is like you could let this go dry so easily, and the sand, okay, creates, as we know, a little barrier. Now watch, and if you just like percolate it in, the solvent like slows it down enough, and you see how it's making a nice little barrier on top of the column. And now all we have to do is run it down onto the column. So in the meantime, as this drips down, and I want to reiterate this idea that you have to keep solvent. The solvent always has to be above that sand bed. If it's below the sand bed, you've ruined the column, essentially. The column has to have this nice, smooth look to it. The mistake students frequently make is they start putting the sand in before it coalesces, and then they end up with sand like in the middle of their column. That's like a common error. And that's why we're practicing for a week. Okay, so when you're ready to go, this is how it's going to work. When we load the sample on the column, we may or may not be able to see the compound coming off. So you're going to have a rack like this loaded with test tubes. And you're going to collect the material that's coming off the column in fractions. And then every so many tubes, you're going to run a TLC plate, look at it under a lamp, look at it with the stain, and find your compound. When you find the vials that have your compound in them, you're going to combine them, rotovap them down, and that'll be your pure compound. I don't know if that makes any sense. Like if I just collected it all at once, okay, and it's running down slowly, I could pipette some of this out, which I might do. But typically you would just let it run down. So this whole thing will be filled with test tubes. You might have 40 test tubes, okay? You will notice that on these, which we borrow from biochemistry, there are numbers, okay, that are actually engraved into this. So you start collecting. In the beginning, nothing's going to be coming off. But as time goes on, eventually a compound will elute off. You might not be able to see it. It might be colorless. So how do you find out? You take spots, put them on a TLC plate, like say every 3 tubes, or every 4 tubes, or every 5 tubes. We have some snazzy ways to figure this out. You can look at it under the UV lamp and just see, do I see spots? When you find spots that have the same RF value as your projected product and stain the way your projected product this week will, which is red, okay, the alpha beta unsaturated ketone stain red, you will take those tubes, combine, kind of zero in on them, combine them together, put them in a rotovap, and rotovap the dichloromethane off. Then the dry material left over will be your pure compound, which you'll take on in other reactions. And again, this is a bit of a practice, this particular thing. That's the part of it people don't get a lot. The other thing I would say to you is that to realize this is upside down. Like when you're on a TLC plate, the solvent runs this way, it runs up. And this, as you can see, the solvent is running down, right? It's coming down. So think about it. It's going to be the other way around. When I load the compound onto the top of this column, the stuff that's less polar is going to come off first. And the stuff that's more polar is going to come off later because it's going to stick to the silica gel. And the stuff that's really polar will spend more time on the silica gel, and the stuff that's less polar will spend more time in the solvent, which is running in the opposite direction. So things that have what you would call high RFs on a TLC plate will be the first to come off on a column. Okay, so we're almost down to the bottom. All right, my sample I think is ready to go. Okay, so we have a little more. I'm going to see if I can speed this up a hair. This is where you find when you pack it, it's kind of variable. Okay, now I just took this off to see if it would drip a little faster. But you do have to keep it full. Always have dichloromethane ready. And by the way, you can recycle this. If you just used it in packing, there's no reason why you can't recycle that. I wish I had a little vacuum. What the professional chemists do, right, is they do these under pressure. So in other words, they actually take like a nitrogen source and they'll put like a cap on the top and they put pressure. These columns are not amenable to that because these columns are very poorly constructed. I guess they're what you would call kind of low-grade columns. But if you put pressure on this, it will blow up, for sure. Definitely. Okay, so we're almost there. All right, so how am I going to load my sample? what I'm going to do is I'm going to take a glass pipette and a bulb, and it should be nice and clean. I'm still waiting for that to come down. This column actually has a really nice rate. Why am I not running test tubes yet? Because I don't have any sample on there yet. The only thing coming off right now is dichloromethane. Are we okay? Even if I made it this far, I'd be okay. I'm okay? So far, John? Okay, so my sample, you're going to put your sample up in a pipette like this. I have to come down a little lower. I'm going to start loading it when it gets down to the sand. It's so exciting to watch, I know. When you're actually running it, it's actually extremely important to keep it full, because look at how it's going slower now. Why is it going slower right now? Think about the physics behind that, right? It slows down. So a lot of students, they don't keep the column full. You got to keep the column full, okay? If you keep the column full, it runs faster. It's running so slow right now because we're running out of liquid. All right, so I'm getting to the bottom of this thing. I'm going to stop it in a second. The sand is your buffer zone, so you can go right down to the sand. You just can't get the white part dry. Look how slow that's going. It was going so fast before. In the beginning, some people don't like this, but by the time they've done a couple columns, they love it because it's like a fantastic way to separate things. All right, a little lower, boom, boom, boom. Okay, so I'm going to get ready to stop it. So when you get down close to the sand, get ready. 1, 2, 3, 4, 5, boom. I just stopped it. Okay? Now I'm going to start loading. Loading should be a trickling process. I'm only going to load about half of this sample because it's a big sample. I'm just going to load it. You trickle it down the sides. The reason you trickle it down the sides is because you don't want to upset the bed. If you upset the bed, it becomes uneven. If it becomes uneven, the band runs in a crooked fashion. Okay, so now what am I going to do? I'm going to let it start running again. So now I let it run onto the column. Nothing's coming off yet. It's not even coming on yet. And this is going to be a really nice band, I think, because I have a nice flat looking column. It's like pretty well packed. So if I were you guys, I would go down to the level of the sand. Now again, why didn't I load it all? I had a ridiculously large sample. Now notice it's going onto the column right now. So now it's being absorbed. I got to stop it before it gets dry. It's okay if the sand gets a little dry. Now, you don't just fill it up. This is the mistake. If you fill it up, all the compound that's up in the sand is going to dilute up into this area, and it's going to come like trickling through. What you do is you rinse down with pure dichloromethane. So I'm rinsing down the walls. Notice how it's yellow? This is the residual going in. Okay? And if you're really an artist at this, you would do that, put a little less solvent. So now I'm running it in again. I'm probably going to do this 2 or 3 times. Notice the beautiful orange band on the column. That's the compound plus some contaminants. And this is actually a warfarin mixture. It has warfarin in it, which we're going to start working on a little bit this week. So notice it going in. It's starting to make its way down the silica gel. It's starting to separate into different levels of concentration. You're actually seeing it banded out. That's why it's called chromatography. Color, right? You should see color. This is a colored compound. Your compound could be white and you see nothing. The only way you're going to know is by what you collect. Okay, now, again, I'm going to bring it down to the sand. You guys, what I would recommend, get it down to the sand. Okay, again, your grad students are going to tell you all these different ways to do things, which is fine. I'm really into creativity and different methodologies. Now, notice how my supernatant liquid, now it looks much cleaner. So I think I'm ready to run, but I'm going to run this in. Okay, we're almost done. Run, 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 run. Look at the beautiful bands in that. So you see I have a leading band there, and it's separating into different components. Now, once I feel like that liquid above is pretty clear, I stop it. Okay, I refill it, and this is where I say fill it all the way. And this is where the sand is your ally. The sand, and notice how the supernatant liquid on the top now is no longer colored. Okay, and you would fill this all the way up. I'm just filling it partially, but remember, if it's filled all the way, it's going to run faster. Then what you would do is you get this ready to roll here. You could get it dripping a little bit. And what you do is you put it over your test tubes. Oh my goodness, that was not good. Not good technique by me. So I didn't have that screwed in enough. But you would put it over your test tubes. Now fortunately nothing was coming off. You put it over your test tubes and you'd start, these are small, you'd start filling these about 2/3 of the way. When the test tube's full, you'd switch to another one. And eventually you get to a point where it's, there's actually compound coming off. I don't know if you can see down here, there's actually color down there. So there is a leading band that's already made it to the bottom of this. So there is stuff at the beginning, maybe that's my product. What's the idea behind putting it in fractions? It's because sometimes the bands are really close to each other and they overlap a little bit, and you want to be able to distinguish where you have pure material from overlap, okay? So there'll be a demo in lab also, but I hope you watch this and it helps you run your column in lab. Okay, thanks.